Good afternoon, everyone. So I guess I will give it a head start. I'm going to talk to you today about space sciences and their societal benefits. And my aim is really to introduce a little bit the societal context of science, which is my primary expertise, and then talk briefly about benefits. What does it mean today in a space industry, or let's say in space exploration? And then I will try to narrow it down to astrobiology and show some specific benefits areas and show at least two concrete examples of what those benefits are. So my name is Klara. I am a trained sociocultural anthropologist specialized in science and technology studies. And especially I'm looking into the relations between space and society. So the debate about what is the role of science in society is not new. It's been going on for a couple of decades, of course, as you may be aware. This is my favorite quote. This is Bernard Russell describing what is the impact of science on society, but the length of the impact of science on society, which existed for around about 300 years. Here, Russell limits the time for educated men, but as a sort of economic technique is for about 150 years. So for social sciences and humanist science, it's already been under the radar. But the social study of science as a discipline within social studies has developed from the tradition of the sociology, history, and philosophy of science. Here again mentioned Russell and Kuhn, the theory of scientific revolutions. And the social researchers have really approached sciences as historically, socially, politically, and culturally situated local practices, rather than some sort of uniform, universal value neutral processes of knowledge production. That really means that we are looking at the context of science. This is how science is done, how it relates to the society, what are the people who do science. And here it comes to ethnographic and historical studies of science that provide accounts of the works of scientific communities and social context. So Rabinov has worked on the DNA. Travik has worked with the physicist in Japan. And science has socially embedded and positioned in the configuration of scientific, technological, culture, societal, economic, political, and legal elements. So that means that it's not only context with just society, but with its concrete elements or components that also change in time. So it is also about development of science over time. Let me change. The social study of science, as defined by Yasanov, is somehow described as our shared enterprise to create pockets of sanity, reason, and understanding in a very complex world. Once you're trying to describe a very dynamic processes, which societal processes typically are across a number of cultures or countries, if you like, then you have quite a complex and hard job to do. So that is sort of insider's view on the methodology or our work. So here I get to the societal benefits of space and technologies, which is a bit broader part of how we could think about societal benefits. So what is the societal benefit? So it's typically defined as a measurable change or impact. A measurable change means that once we have developed a methodology, we can see the progress and we can track it across time. The impact, which is slightly different than a benefit, but we are aware, or there is a very clear understanding that those impacts are positive, but also negative. The way at looking at benefits could be twofold. I would say a traditional benefit of science would be that it provides answers, it provides solutions to problems, and to some degree it provides predictions. Emerging benefits, which is mostly what I would like to address today, is showing the societal context and potential spin-off and spin-over benefits. This is the interactions between the science and society, so spillover. Something unexpected also. The benefits are related also to societal reaction to science and change that science has induced, and broader societal, socioeconomic benefits of science and technology. I think this is something you've probably came across already, the socioeconomic benefits. So that is what sort of return of investments science and technology bring back to society. Very typically, we can see that in funding applications. I'm not going to go into great detail in this case here, but it is here. It's part of the benefits. UNESCO, it's one of the ways of approaching what is the role of science for society. Here you have the definition. You can see it from their websites. Science is described as the greatest collective endeavor, and it contributes to ensuring a longer and healthier life. So that is typically the health technologies. It monitors, provide medicines, and etc., etc. So this is a very medical science related definition, but they also mention communication technologies. For us, when we refer to space sciences and astrobiology, of course, a way more important agenda is the one provided by the UNOOSA, the United Nations Office for Outer Space Affairs. When you go to their website, you will see a number of pages dedicated to benefits of space for humankind. Here is the link, and here is the areas that the UN mentions as a potential impact areas of space technologies. I will name them for you. They are starting with agriculture, global health, environment, sustainable development, disasters, education, human settlements, research and development, transportation, communication, humanitarian assistance, and international peace and security. The United Nations, the UNOOSA's agenda, of course, is responsive to the United Nations Sustainable Development Goals agenda. Again, I'm sure you've seen this somewhere already. The United Nations have set 17 interlinked goals that define global, social, environmental, and economic sustainable development priorities in 5 areas. Priorities for the planet, for its people, for prosperity, peace, and partnership. And those goals are often referred to as of existential importance for humanity. So these goals are all interlinked. That is very important. And they are designed to be a blueprint to achieve a better and more sustainable future for all. So it is a call for action by all countries, the poor, the rich, and the middle income. They recognize that ending poverty, which is the Sustainable Development Goal number 1, must go hand in hand with strategies that build economic growth and address a range of social needs, including education, health, social protection, job opportunities, while tackling climate change and environmental protection. So that is the UN SDGs. Here is the link for you, should you wish to visit the website and have a look at the goals. So each of the goals has specific targets. So the 17 goals come down to 169 targets. The UNOOSA is aligning the space for development already with the SDGs. This is again a print screen from their website. This one is dedicated to quality education and gender equity. And also water. This is the website, their page, pardon me, clean water and sanitation, or space for water. I have lost somewhere the description. Let me see. Yes, here, this is the one page I've skipped, I'm sorry. This is how UNOOSA describes what are the benefits of space for humankind. So the UNOOSA works to promote international cooperation in the peaceful use and exploration of space, and this is new, the utilization or use of space technology, space science and technology for sustainable and economic social development. What's very important that space has been recognized as a driver and a tool for sustainable development. And according to UNOOSA, space technologies in general have impact in almost all aspects of development. So you have seen the goals on this slide here. And if you have a little time or if you're familiar with the agenda, you will see that here it really overlaps, especially in agriculture, global health, environment, education, research and development, human settlements, transportation, communication, humanitarian assistance and security. These are some of the targets. This, of course, so let's say global agenda has already been reflected in works of the major space agencies. So here we have the benefits for humanity by NASA. There is not a direct link to the Sustainable Development Goals, but you will see that in areas of health, there is a very clear link. The European Space Agency, the Human and Robotic Exploration Directorate, has a dedicated website called We Explore, You Benefit, where there is a list of success stories that also show what is their benefits to society in general, but they are also concretely linked to Sustainable Development Goals, and so is the huge ESA portal. And in case you're interested in another let's say view of or reading about the benefits that are stemming from space exploration, the International Space Exploration Coordination Group has published a report. It originates from 2013, but it has been updated recently, where you can read more about the benefits. It's typically the International Space Station, of course, and other exploration activities. Now, this is a broader context, and I would like to address, or I would like to focus on the benefits of astrobiology. So I don't know if you had a chance to read a publication collectively written by a number of researchers related to the European Astrobiology Institute. It was the Astrobiology and Society Today. We have touched upon some of the topics, and we have introduced the context in which astrobiology is relevant to societal topics and other way around. We have mostly spoken about science and knowledge production, worldview and ethics, education and outreach, but we have also mentioned technology and innovation. So I will now go one by one through those 4 areas. So, science and knowledge production. It is typically the first thing that people have in mind when they think about societal impact of science. Yes, we do science, we provide answer, and we produce enormous amount of knowledge that is then used by other scientific teams, but also has potentially practical application. Astrobiology is very unique in a sense that it's a very newly formed field of scientific practice and knowledge production that is very multidisciplinary. So astrobiologists typically are people who are able to combine different perspectives. And of course, there is an epistemological issue regarding the boundaries of the disciplines and very status of astrobiology as a science. So the discussion is still going on, but I think astrobiology has been very much established as a field of knowledge. It hasn't been this case, I think, 30 years ago. Some of you might remember those times. It's really weird. I can't see any faces. It's a strange way to talk, but it is the online era, so I need to adapt. If you have, by the way, if you have any comments or any questions, just feel free to drop them in a chat. I should be able to see it here and maybe able to address them right away. So feel free to interact if you like. So coming back to astrobiology as a new knowledge production. Astrobiology as a science presents new directions for social study of science. Of course, having seen astrobiology emerging or being created as this multidisciplinary field of scientific practice, as I've said earlier, it is for a social scientist that works in a social study of science. It's seeing really the new model of science happening, but also scientific revolution, because astrobiology as a search for life beyond Earth has somehow taken over the question that's been dominating the SETI, search for extraterrestrial intelligence, as a way we were searching for life outside of our planet. So there is a little of context in that. Astrobiology is a new knowledge about life. How do we think about life? We think about life in its very basic forms, as life in its origins, or building blocks of life, or even about environments that are suitable for supporting emergence of life. So it's about life as we know it, or maybe as we don't know it. What is it we will find? So astrobiologists, I think, are unique in a way that they need to be able to think about things that don't exist just yet, or have not been found just yet. And this conceptual development in thinking about the other life, or life beyond Earth, if you like, has been recorded by anthropologist Stefan Helmreich already in 2008. He said, we used to think about a life beyond Earth as something very intelligent, while now we're talking about this primitive life, or potential life, or life in its origins. I'm sure you will recognize this photograph of the ALH 84001, the Martian meteorite found in Antarctica. The 1996 publication has provoked a lot of discussion in the science circle, but also in the public and in media about that, about life on Mars. While I have to say, before this, what we've known about life on Mars basically originated from our science fiction stories. And this is the most famous one, the H.G. Wells's The War of the Worlds. There's been dominating popular thinking, or if you like, public thinking about life beyond Earth, or life on Mars, for over a century for sure. A very popular story. It's been adopted into more than 300 movies of the same title, The War of the Worlds. The Steven Spielberg's 2005 adaptation has been already distributed to 67 countries worldwide. So this is a popular global imagination or idea about what Martian life would or could look like, and what is the contact going to be like. It is a science fiction story, of course, but it is something that's present in popular thinking about other life. It goes very far. There is a conceptual confusion about what that other life is. This is how the Telegraph informed the public about the first ever astrobiological meeting organized by the Vatican. So as you see, the imagination and the science fiction imprints are there. While today our thinking about searching for life or other life translates into space missions, this is the Perseverance mission and the BBC News, that they begin to the key drive to find life on Mars. We also see already that this transformation in conceptual thinking about what that other life is. So we've seen the hostile Martians, we've seen the aliens, but currently we also can see this sort of ideas about how life could have evolved into animals or primitive life on other planets. This is the Discovery Channel's program 2010 with Stephen Hawking. And yes, so thinking about how we think about other life and the worldview, we can say that the contemporary societal implications related of astrobiology are also related to topics of cultural, ethical, educational, political, and legal importance. So we've seen a lot of cultural formations or new cultural, I wouldn't say icons, but I would say visuals being produced as a sort of a result or effect of new thinking about the life beyond Earth related to astrobiological concepts. But typically, we've discussed also in the white paper the societal reaction to the discovery of extraterrestrial life, which of course, if astrobiologists succeed and a new life will be discovered, then we deal with the ages-old questions: who are we, where do we come from, and we can anticipate enormous or at least huge reaction to the discovery. Another thing that is the commercial and industrial use of space. So we've seen in the new space age, we've seen a lot of commercial entities entering space industry and let's say private plans of using space. If there will be some sort of context or clash with conduct of science, we don't know yet, but it is potentially there. Especially, for example, if somebody is going to build a habitat on Mars, and it happens to be a site of astrobiological or scientific interest, how this will play out. This, my colleague Eric Persson has discussed the moral and others have discussed the moral and legal status of extraterrestrial life. So if we discover life elsewhere, how do we sort of accept it or frame it within our thinking of living things? Should it be an animal or a living creature? We don't know that. Environmental ethics in space is becoming a very important topic for discussion, especially when we talk about using the resources, Moon, Mars again, and colonization, of course. And technological innovation and commerce, which is something I will address a little bit later. So the worldview, I suggest you check work of Ian Crawford, The Expanding Worldview, is a beautiful book about the whole context of SETI astrobiology and how we see the world. I believe that astrobiology produces new cultural meanings and inspires new stories about science, human life, its past, present, future, its origins, and its place in the universe. These are, again, crucial societal questions. And hopefully we will have an answer at some point soon. So, yes, this is where I was. And the next area of benefits I would like to mention is education and outreach. We've seen, especially over the past 10 years, this growing role, but also representation of astrobiology in secondary and tertiary education. We've seen even the formation of the European Astrobiology Institute in 2019, I believe it was May, yes. We've seen new school curricula being updated, new programs, doctoral, postdoctoral positions being announced, summer schools and training, and growing number of academic publications. We've also seen science dissemination and outreach, and here I would like to highlight the role again of the European Astrobiology Institute and the Science Communication Group. I think it's the working group that also is addressing a number of topics. One of them is public understanding of science, this conceptual clearance about the subject of astrobiology, what it does, what it doesn't do, and what its potential for society. And the last area is technology, innovation, and economy. So here the link for people who work in science is not very clear, or at least in my experience. But we've seen in the past years that the technologies developed for astrobiology research, especially for the space missions to Mars, are leveraging or may leverage innovative solutions and further contribute to sustainable economic development on Earth. So these are basically the results of applied science and technologies, areas robotics, energy solutions, and sample analysis. I would like to highlight that this is an ongoing process. It's something we just see emerging and happening, and hopefully there will be more to come. And I have for you two examples from a research I've recently completed with the European Space Agency. There are two success stories. One of them is related a bit more general to space exploration, and the other one is purely related to astrobiology. So technology and innovation. The first case is spectrometry. The device was originally developed as a novel infrared spectrometer. It was intended to measure vapor on Mars. A spin-out company from the UK, funded by the Science and Technology Facilities Council and European Space Agency Business Incubation Centre, has taken this technology and created a product that provides monitoring solutions for over a variety of industries and applications. And really, the impact is global, and the industries or applications include aluminium refining, bioethanol and biofuels, chemicals, oil refining, industrial biotechnology, oil and gas, pharma and biopharmaceutical. It is commercially viable application on Earth, and it is distributed globally, as I said. So if you would like to read or have a look at the entire case study, I suggest you go to ubenefitspaceflightesa.int, and you will see in success stories the entire success story and description of the details. From my perspective, it's interesting as then the research and exploration leads to technological innovation, then leads to business opportunity that generates economic value, but also another benefit, which is the improvement of manufacturing processes. So that is the first one. And the second one is the new miniature instruments. This technology was originally aimed to develop the sensor, optogalvanic sensor system for a lander or a rover, Martian lander or a rover, to measure the C13-C12 ratio in the atmosphere and the regolith or bedrock of Mars. It was pioneered by the Angstrom Space Technology Center of Sweden, Uppsala University. So miniaturized instruments for astrobiology. A spin-off, a four-state system, have taken the sensor, essentially designed for search for life on Mars, and developed a solution that now helps to save the lives of babies that were prematurely born in Sweden. So they've just piloted this technology in one of the hospitals in Sweden. The technology can handle samples, can handle minute sample amounts, I'm sorry, ideal for monitoring blood gases in infants. So it's non-invasive. It can detect emergencies and analyze much lower gas flows through the skin quickly and without heating the skin. So for prematurely born babies, this is a life-changing technology. It can save a lot of lives. So here we see that somehow from research and space exploration, somebody has taken this innovative idea and created it into business opportunity, but at the same time provides immense societal value, health benefits, and at the same time it contributes to the Sustainable Development Goal number 3, health and well-being. So it's something that probably no one could have predicted at the time when the funding application to develop the sensor or instrument for astrobiology has been submitted. But a couple of years later, we have a working technology in a hospital. The full case study is available here. Again, ubenefitspaceflightesa.int. Here you see a picture of that tiny little patch that is basically then laid on the skin of the newborn and does the not analysis, the sample collection, which I think is impressive, to say the least. So 29 minutes in my talk, I'm going to summarize that the benefits of astrobiology, the obvious one, which is the contribution to science and new knowledge, and the worldview change, are also in education, inspiration, about the way we think about the world, culture, but also technology, innovation, and ultimately economy. It seems that technologies developed for astrobiological research on Mars prove to have the unique potential to leverage innovative solutions and further contribute to sustainable development on Earth in the near future. And with that, I'm going to thank you for your attention, and I will be happy to take your questions.
Thank you. It was really interesting. And also, I'm glad you state that you also find that the most important contribution to societal evolution is actually in basically being interesting and being good science. That is reassuring, because just because we don't build anything that someone can sell to millions doesn't mean we are not relevant. And I share your sentiment that interesting a public of sorts in these kinds of questions is basically a non-issue. Whenever I go and give a talk or something, everyone is inanely interested. I mean, anything to do with space is interesting. Anything to do with the origins of life is interesting, and combining the two, that's just a big thing. So
thank you. I really wanted to balance it out because, this immense cultural impact is very clear. Search for life, everybody is very interested, but ultimately, astrobiology produces a lot of knowledge. So just the amount of work that has been published in the past 10 years is impressive. But also, in some of the cases, we see it generates benefits to health very unexpectedly. How would you connect search for life on Mars with a Swedish hospital? And yet the link is there. So I believe it is emerging field. I believe if we follow the very specific case studies, we'll be able to see more of those unexpected applications in the near future. And I believe even if it's, no matter what it is, if it's a contribution to economy or a contribution to education or inspiration, it is a benefit of science, and as such should be promoted.
Yeah.
Thank you, Klara, for a very nice talk. Very often I get questions from my friends or from unknown people like, what are you doing? What is this for? The bread is not cheaper. What would you answer in a simple words to that questions? I mean, it's important for me to do science, but how to answer in a simple way in a few words to that questions?
I believe part of the benefits framework or understanding the benefits of space exploration are motivated by the need to explain how we spend public money and how what we do delivers science but also generates other value to society. And it is ultimately, people always ask, even for me, for social sciences, why is your work important? What does it really change? What value does it bring? And I think that I believe that if you think about your work from the benefits perspective, you will be able to identify areas in which your work does something for the society. I think it will be typically education. The work I do will help children to understand better the formation of planets or the atmospheric conditions on Mars. So that I would say is contribution to their education. You will update the school curricula at this point. Or I don't know. I typically suggest to people just to take a sheet of paper and try to think about their work from this external perspective. We tend to be very focused on what we have just ahead of us, and we often forget to see the context. It's not an easy thing to do, but I found it very useful. Or let's start with typical benefits of science. Yes. I don't know if that answers your question, or if you would like to.
Yes, more or less. The problem is that for the many people, the knowledge has no value, and this is a problem, but we cannot solve it probably.
I've seen it somewhere. Somebody tries to evaluate the value, I mean, economic value of Einstein's work. And a typical typical example is the Apollo program. So we go to the moon. Why would you go to the moon other than being the first? So that was very successful. But today we see a lot of things that are the result of the American space program, the new technologies, the communications, materials. What I encounter a lot, it's very hard to do ex ante analysis, that is predict how the knowledge will be applied or how will it be used, and even technologies, you know, what it's going to be good for. It is the ex ante, when we see it, something is working very often in a very unexpected way, then we can attribute the societal value to the technology.
Maybe this could be your next book, to write down the concrete examples and these interesting stories, like the one in hospital in Sweden, to write it down, and this would be, I think, really important and quite interesting.
This was actually the nature of my research fellowship I've done for the European Space Agency. So the website you've seen, if you have a time or you're interested, go to the website and search the success stories, and you will see a very, I think, a very good or nice collection. It wasn't just my work, it's something that the team has been working on since, I think, 2016 or 17, where you'll see a collection of stories. Again, it is the ex post analysis. When you go to the NASA website, you will also see that they have a list of the benefits of the International Space Station, yes. And they also have a very good economical analysis. Yeah, that is their strong point, I think.
Okay, thank you very much. I noted it down. Thank you.
By the way, in some funding applications, people are already being asked what is the anticipated social or societal value of your work. I've checked the NASA Astrobiology. They typically limit it to education and outreach.